This is Wilfried, the PCB designer again. ZAC finished the fan-out and breakout of all DDR4 DQ signals coming from the memory chips to the FPGA, and our SI-PI expert Rory verified the power integrity of the P1V2 power net of the DDR4 circuit. Based on this, I want to do the second FPGA pin optimization step to reduce the last netline crossings and to pave the way for sketch routing, which is done by ZAC later. We saw in the previous video that I/O optimizer is capable to guide during part placement and to support the fan-out and breakout process. In this phase of the design, we are using FPGA I/O optimization to improve the pin assignment based on the pre-routed signals, taking into account the layer usage. Before we can start the second optimization run, we need to use the methods and functions shown by ZAC to complete the fan-out and breakout for all other signals. The best practice approach to optimize the FPGA pin assignment is that breakouts will be extended until all trace ends from the memory and the FPGA, as well as all other signals, are directly facing each other. For this reason, we are using the sketch planning technology to speed up this process as much as possible. On layer 2, 4 sketch plans are placed, and the netlines from each byte lanes are added to the corresponding sketch plan. Semi-trunc is used to finish the routing. We see that it automatically adds wires and the breakouts. In comparison to manual routing, this is an enormous time saver. Sketch Planner is also based on the sketch routing technology, and routing quality and to follow the layout designer's intent is most important. This means push and shove is not allowed. We see 2 open netlines which can be completed easily. The traces from the memories will be extended further by using multiplow. With push and shove, I can clean up the routing afterwards. After all this, we want to use area cut trace to unify all traces. This is a major step to ensure unraveling quality of I/O optimizer and also guarantees better routing behavior later. I am now going to repeat the same steps on all other layers and for all other signals on the board. All fanouts, breakouts, and some additional routing is finished. We can now mark our DDR4 DQs to get a better overview of the results from the second run with I/O optimizer. For this reason, I'm selecting all DQs on layer 2 and mark them with the right mouse button. We saw in a previous video that I/O optimizer is capable to guide during the part placement and to support the fan-out and breakout process. In this phase of the design, we are using FPGA I/O optimization to improve the pin assignment based on the pre-routed signals, taking into account the layer usage. As we see, the clear advantage of this second step is a much faster routing time. The support of optimization between trace ends guarantees layer reduction and minimum net length. All this reduces signal integrity issues, which makes our SI-PI engineer Rory very happy. The engineering change order process does not only write back data to the PCB domain. It fully supports a bidirectional exchange of native file formats from FPGA vendors like Intel, Xilinx, Lattice, and Microsemi. In our case, we are using a VHDL signal source and a QSF constraint file for the pin location. SEC can now use expedition routing technology to finish this optimized set of signals.